Yes, here we are. Hey everybody. Hope everybody's doing good today. I'm having slanting camera problems. There we go. There we go. Does this look a little zoomed in on me on this head? I don't know. I can try to back up a little bit. That's a little better. That's a little better. So hey everybody. It is 2 hours UTC on the 15th of February 2018. This is a live stream called Astronomy Daily Live, and we do this every single day. A bunch of us gather in a circle and have a seat, stand if you want to, grab a drink. Uh-oh, I forgot mine. Uh, and, you know, get away from the TV, get away from the news for a while, get away from everything and focus in on uh, a passion that is the universe and being incredibly curious about all of it and you know trying trying to think about why don't I understand this. Frustrating, sometimes, but absolutely gorgeous. The whole thing is just absolutely fabulous. You know what? I'm going to take a minute. I'm going to take a minute and fill fill my empty jug with some kind of chemical. I have to decide. So I'm going to do this early in the live stream. I will be right back because I'm going to need this. I'm going to need this. So I will be right back. Promise. Promise. Fucking kitty doesn't really like this idea of talking out loud. Sorry about that. I've got a I've got a screaming kitty over here. She doesn't really understand why I'm talking out loud to absolutely nothing at all, especially why I'm not talking out loud to her. So she just uh, uh, swore at me, and oh well. So hope everybody's doing good. This is Astronomy Daily Live every single day, starting at 2 hours UTC, and yeah, usually going for about an hour or so, maybe a little bit over. I do respect your time, so I think a good hour every day is pretty good. When I started thinking about doing this live cast, it's sort of like, okay, yeah, it has to be every day because that's sort of one of the holes that I want to fill in the current streaming slash podcast space. But then, the question was, how long? Should it be 10 minutes where I just sort of, do, 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 and here's the headline, do, 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 or, half an hour so I can get into maybe one topic, maybe, uh, or should it be an hour? Should it be an hour? And I think an hour um, seems to be working out pretty well. We definitely appreciate comments about that. Also, comments about going more than an hour. Some of the live streams that I watch go 3, 4, 5 hours, um, 8 hours. So that's not happening every day, though. Of course, that's happening every week, maybe a couple times a week. So is going 3 or 4 hours? Is that something interesting? I I I don't know if I'd necessarily be interested in doing that. I think sort of a burst of an hour, especially since it's every single day. So look, let's look at it this way. Okay, let's look at it this way. I am doing this approximately about 70 minutes. Let's just say, okay, let's just say that I do this 70 minutes a day, okay, for 7 days a week. And of course, oops, see, always a good scientist always has a hand calculator within reach, always. A good scientist does. So 70 times 7 is, of course, 490 minutes. Okay, divide that by 60 to get the number of hours. And you get 8.17 hours, which is 8 hours and 10 minutes. So I'm actually streaming longer than any other stream in terms of astronomy, or any of the streams that I watch per week on a per week basis. I'm streaming longer than anybody. So I don't think that I need to do any more than an hour. That seems, 8 hours and 10 minutes a week. Wow, that's, looking at it like that, it's like, yeah, I'm beating everybody. Oh, did I do that? Hey, Uncle Bill. Hope everything is good over there. I might have just hosed my machine again. Let's see if I can save it. Oh, I might have saved it. I forget. I've been getting on to the YouTube um, stream early, so when it goes live, it just automatically starts. And the Linux machine is the one that freezes that freezes when any live stream is running. Now I can play YouTube videos um, pretty reliably, okay, but if it's a live stream, it it completely freezes the system. I can't move the mouse. I have no keyboard control. I have nothing. There's only one thing I can do, and because there's only one thing I can do, I actually do two things. Okay. The first thing that I do is I make a lot of loud noises, and I make up a lot of new words. Make up a lot of new words and make a lot of loud noises. And then I hold the power button in until the machine goes off. All I can do. And yeah, it's crazy. But hey there, No Till Tom. Hope everything's going well. Hope your ladies are happy and praying uh, uh, deeply. So yeah, glad you could stop in and say hi. Stop in anytime. I am here. I'm here. And in fact, I should say we're here. And that's a collective we. So yeah, feel free to come in any time. This live stream is a very casual, fun, um, skeptical, um, but open-minded conversation about astronomy and sort of the related things. Science in general. Astronomy is a very, very, very broad. It's I would say the broadest of the sciences. It really encompasses uh, a lot of stuff. Uh, it encompasses pretty much everything, right? So yeah. Oh, by the way, when I was away, the chemical of choice tonight, I had to go with the dihydrogen oxide tonight. So it's very energetic, and yeah, that's sort of how I'm feeling tonight. Is uh, energetic. So cheers. That is not gonna last. That's some nice dihydrogen oxide tonight. It's exceptional. I That must be a new batch. That must be a new batch because yeah, it's got some zing. It's got some zing to it. All right, we are 11 minutes in, so it's 2 hours 11 minutes UTC. Uh, howdy to everybody viewing live, and howdy to everybody viewing in the future. Haven't talked much astronomy yet, so let's get into that. I'm also going to go over to my Discord channel, and actually, I'm going to do this, and then I'm going to do that. Go over to my Discord channel, and just make sure that there isn't any exciting action over there. And I don't see any yet, but that's okay. That means I haven't missed anything. The other thing that I want to do is I want to run my live stream on my smartphone, is over here, like that. Make sure that that's all okay. I'm going to check the audio really quick when it comes up here. Groovy, groovy, groovy. We have good audio. It there it can only get better. The audio can only get better. Video can only get better. So bear with me. This isn't an apology. It's just bear with me. I understand that the quality of the production is uh, doesn't match up to some extremely nice standards. But I'll get there. I'll get there. No worries. Yeah, it's pretty easy to do that. So yeah, so let's get into some astronomical talk. Let's see. I guess I can remind you all about my measuring the distance to the moon project. If you're interested in participating in that, just throw me an email, cosmiclettuce@gmail.com, and just say that you're interested in finding out more about helping with measuring the distance to the moon. This is the kind of yeah, well, it's just a fun and easy way to do something kind of interesting, and you know, uh, you can tell your friends that you helped measure the distance to the moon, and at that particular date and time, the moon was X number of kilometers away, or X number of miles away, And yeah, that's that's kind of cool, to both impress yourself and impress your friends at the same time. So yeah, if you're interested in participating in that, throw me an email. Um, all you need for that is a digital camera, and what you're going to do is at a designated date and time, you are going to photograph the moon, and at that um, date and time, the moon is going to be next to either a bright star or a bright planet. So you need to be able to photograph both the moon and the planet. And you might have to adjust the exposure time. Um, you can zoom in a little bit if you want. Doesn't particularly matter as long as what the final result is a moon and a bright either star or planet. And doing this for the first time uh, very very soon in a few days. Um, at 3 hours 30 minutes UTC on the 20 on on the uh, on the 23rd of February. I would like you to take this photograph of the moon. It's going to be really really near a star called Aldebaran, and um, that star is in the constellation of Taurus. It's also, I don't think it's associated with, but it's in the line of sight of a cluster of stars called the Hyades, and it's sort of the head of the bowl of Taurus. Taurus the bowl, and so this is the head. Um, Aldebaran is supposed to be one of his eyes, right? Or the eye that you can see, is he's sort of charging sideways. So it's the eye of the bowl. Yeah. So the moon is going to be pretty near that. So that makes a great opportunity because to photograph a fairly bright star, even in the city, is very very easy, and you'll definitely be able to see the moon. So yeah, you just have to photograph them both um, in the same picture. Uh, you email that picture or preferably pictures. Take a bunch of them, as many as you want. I don't care. I guess I don't care. Yeah, if you really want to do hundreds, okay, okay. Maybe we'll have to, if if you do more than a few, I would say let's put them on like a Google Drive or something like that instead. And in fact, maybe I will set up a Google Drive for that. I'll have to figure out how to do that, but yeah, I'll figure that out. So yeah, maybe I'll set up a Google Drive so you don't have to email me, and then you can send me as many pictures as you want. And actually, the more images we get, the the better our precision, or at least our measurement of precision, will be. So yeah. So if you're interested in that, let me know. It's you know it's pretty simple on your end, and it's going to be pretty simple on my end too. It's just a little bit of math. Uh, no big deal. Some trigonometry. Some basic trig. Uh, So shouldn't be any problem at all. We're going to be doing this for a few months, so there's going to be lots of opportunities to participate. I've been contacted, from people around the world. So this particular moonshot is going to be favorable, I think, for people in at least the Western Hemisphere. Uh, so people in Europe, Asia, you're not going to see it. You're not going to see it. Moon's going to be on the other side of the planet from you, so you're not going to be able to see it this time. Um, but as I said, I'm gonna run this for at least a few months. Get lots of data points. Maybe try to do it every like every other week, um, first quarter, and around third quarter. Um, but if there's an opportunity timeouts. Yeah, I'm just going to try to do it. Yeah, maybe once a week, once every 2 weeks for a few months. Get some data points in that'll help with the accuracy. So yeah, I think that's kind of a fun project. The result will be a paper, uh, and all the participants in this project will be co-authors, which means you'll be able to not only make a contribution in terms of what you're doing with collecting the data, but you'll also have the opportunity to participate in the writing of the paper itself. So that's something that citizen science, so-called citizen science, uh, doesn't allow, or at least that not that I'm aware of, and not that it's allowed or not. It's just not. It's not part of the program. So-called citizen science is actually citizen data collection. Um, so and there's a big difference. There's a big difference. So I'm offering a little bit more of the science. So you can actually, I mean, if you want to, you can be a part of the analysis. You can be, as I said, part of the writing of the paper. Yeah, whatever whatever you want because you're a co-author, and as a co-author, you have certain rights, and one of those rights is to have a say in sort of the presentation of um, of the paper, and you know um, being able to also have a say in the analysis of the data. So if you just want to take a picture and that's it, that is good for me too. So any level of participation, and that's also what this live stream is all about. Anybody anybody is welcome here. You can be a newbie, you can be an amateur, you can be like an advanced amateur, uh, and you can be a pro, and you're all welcome here. I think you know uh, I I'm able to communicate at pretty much any level that you want. And jumping around between levels, if you want to call them that. Um, yeah, no problem at all. Uh, any level, any level at all, and that's how I want this measuring the distance to the moon project to be as well. Is that you will be a co-author, I guess, unless you tell me otherwise, um, which means that you have full rights to participate in the whole thing, and that means the collection of the data itself. I will be collecting data as well. So yeah, it's very very fun, very very cool, and yeah, this paper will be published somewhere, somehow. I can't necessarily say that it's going to be published in like, a professional journal or anything, but it will be published in that it will be made public. So, and anybody will be able, to view it and reference it and etc. Yeah, but yeah, I may try to find or at least ask around to see what publications might be interested in publishing this. So who knows? Who knows? We'll uh, we'll figure that out. And if you have any suggestions in terms of that, let me know. Cheers. Yeah, that must be a fresh batch. Got to be. Got to be. All right, cool. I'm going to, since I don't see any questions or comments in the chat, I'm going to show you another website that I don't frequent enough. I definitely don't frequent this one enough, but let's go over there anyway. So I'm going to share my screen. We're going to go to infinity, and then I'm going to come over here, and I'm going to go to the website for the Solar Dynamics Observatory. Solar Dynamics Observatory. And as the name implies, and as you can see, this is another observatory spacecraft that is observing the sun in many wavelengths, many different wavelengths. So what I do here is I go up to data. Whenever I go onto any of these mission sites, that's sort of the first place that I sort of look for, or look, I try to see if data is available in any form. So what I do is I go to the sun now, and this just sort of provides an overview of the data products that are available. Okay, so this is the sun taken, I would think, at the same time through different filters that allow these cameras to look at the sun in different wavelengths of light. So up here, maybe, I hope you can see, this says AIA 193. So the 193 is the wavelength in angstroms. So 193 angstroms, 304 angstroms, 171, 211, 131, 335, 94, 1600, 1700. And then what they do is they apply sort of some, well, they just sort of add three together, probably sort of randomly, to give it a little bit of color, interesting color. And they have a magnetogram, an intensitygram. They have two magnetograms. One is grayscale and the other is colorized. They have an intensitygram. They have a this is pretty much this guy here. I should say this one. Yeah, the intensitygram, I would say, is probably the closest thing to sort of the visible light image. Oh, and then they have a bunch of other stuff down here showing different sections and what's going on elsewhere on the sun, not just the half that we can see, because of course we can only see half of the sun at a time. There's another half on the other side. Might call that the dark side of the sun. But with each one of these, you can look at it. You can see sort of the numbers below. So I'm just going to go on to this first one here. These numbers below are just different sized images, so 4096 by 4096, 2048 by 2048, etc. They also have videos, which are kind of fun and neat. So yeah, let's just load up one of the big ones here. You can really see the highest resolution. Hey there, Susan. We are looking at the sun. See, you probably didn't know this, but you can look at the sun at night, and that is precisely what we're doing now. So that is the sun as of, well, the time will be on the bottom. So let's just let this completely load. This is a big, yeah, Susan, you really got to watch out for Uncle Bill there. He is a ninja, and he seconds seconds after you came on, he's like completely checked you and 100 other people out. So he is like the ninja dude. He's watching like 50 live streams at the same time, and participating in them all and having reasonable conversations with them all. So he's absolutely amazing, great supporter. Been here pretty much from the beginning. It's been yeah, it's officially been just a a month and a day. So I'm not going to keep track of that. That's kind of boring, you know, to keep track of. So yeah, I probably won't. Anyway, here's the sun as of, all right, well, it's as of 21 minutes ago. So that's not exactly a live image, but yeah, we can look at the sun at night. Is that cool or what? So um, this big dark area up here is what's called a coronal hole. It's a if you sort of, you can sort of see this a little bit. This, most of the stuff that you're seeing here is what is called the solar corona. It's sort of like the atmosphere of the sun, and so you know you can sort of look on the edge here, right? There's low spots and there's high spots, and then here's low spots again and high spots again. That's that's sort of what a hole is. It's just where whatever this, you know, material is, it isn't really there. So uh, what happens as a result? There's a whole bunch of stuff being spewed out of these dark holes, and mainly you know, like protons, I think alpha particles, which are helium nuclei, that kind of stuff, and you know, directly in the center of the sun is exactly facing us. So this is angled up a little bit. It's angled up. So this isn't going to be like a direct hit. And you know, this is like a, um, think of it um, like a hose outside, you know, shooting water out and spinning. So it's sort of like that. And so it's no big deal. These things happen all the time, and yeah. But anyway, so there's a coronal hole. There's usually coronal holes at the poles as well. So this is the north pole of the sun up here, and here's the south pole of the sun down here. And there are usually holes here, and these are very dynamic, very dynamic places. Now I want to remember. I want to show you another site that, and maybe Uncle Bill, maybe you know what this site is. It's the site that shows all the live solar images, all the movies and everything. What's it called? What's it called? Maybe it's not. It's not like H new. No. Oh, I can't remember what it's called. I'm not prepared. I'm not prepared. Hmm. Let me see if I can. Let me see if I can. Um, Movies of the Sun. 5. Not gonna get me anywhere at all. No. It's gonna get me Sun TV. All right, that's not gonna help at all. I'll try to find that site and get back to you on that. In the meantime, we can go back here and I'll just move around this site a little bit for you. So let's see. This is a way to. Let's just look at the daily movies. That's basically what I was going to show you anyway. So we can select our favorite date here. Let's just do it for the 12th. And so there's all the movies for today. Let's just look. Were we looking at the 131? I think so. Let's see what this does. I don't remember if I've ever watched this or not. I'm going to take a million years to load. Oh, look at it. Play it. Probably going to take a million years to load. Oh, no, that's not too bad. Got to do a whole day's worth, though. So this is obviously a different wavelength than what we were looking at before. This is not looking at the corona at all. This is looking, I believe this is looking at a layer of the sun called the chromosphere. I'm not seeing it updating. Oh, I guess it is updating. So you can see the date and time down here when that stupid thing isn't in the way. I don't know why it's still there. Oh, that's not going to load very fast. I'm just impatient. Impatient. Anyway, did we zoom in on this? I don't think we did. See that? You get the full high-res view of that coronal hole. So it's pretty cool. There actually is useful information in this. So this is sort of calibrated data that one could use to do some interesting science. I just I think it's fabulous. I mean, look at all these little swirlies in here, and yeah, it's a wild place. Wild place. You can fit you can fit quite a few Earths across here. I want to say that you can fit about 100 Earths across there. Maybe not quite that many. Yeah, it's a big place. It's a big place for sure. So let's see. I'm going to go back here. Let's just do the browse data and see. Let me see what we can do here. 12. Let's get a shorter amount of time. So 12 from 0 hours. Let's go to 6 hours. Let's just go 6 hours, 6 o'clock. And we'll do that one. And we'll do 512 by 512 because that's smaller and it'll take a little less time to load. Stand by, your movie is being created. With a very, very comforting infinity sign. Oh, I see. It makes a movie for me. All right, where did this put it? Okay, it's in downloads Astro. Okay, so I can save it there, and then I can go over here and see computing in real time. Where's my downloads? I don't know where my downloads are. We go this way. Downloads, Astro. That must be it right there. So let's take a look at that. I assume it's finished. Come on, Slowpoke. It's somewhere. Didn't it start? There it's starting. No. Let's make this bigger. See, look at that. There we go. So this is just 6 worth of data. You can sort of see interesting things going on there. I think I'm going to download a little bit more, if you don't mind, because that's pretty exciting. Let's go back here. I mean, you can spend hours doing this, right? Just hours looking at all this stuff. I really want to do that coronal hole one. That was this one, right? I want to see that coronal hole. What's wrong with my start date, huh? 212 at 00. What's wrong with that? 215. I don't want 215. I want 213. 213 at 00. 00. Okay, movie being created with the very comforting infinity sign. We'll sing a little song. Here we go. Okay, so let's do that. And that's downloading. I can see it downloading here. And when that's finished, we will pull it up. Yeah, Susan, there are holes in the sun all the time. It sort of depends on how you look at it, though, right? Because, I mean, if you look at it one way and are looking at the corona, then you might see some holes. But if you look deeper down into the sun, yeah, you're not going to see those. So it's almost sort of a matter of perspective. Almost. They're definitely there, but now that happens all the time. Happens all the time. Okay, here we go. So here's a day's worth. A day's worth instead. You can sort of see the clock when that thing isn't in the way on the bottom. And you can see the coronal hole sort of spinning in there. So that's a whole day's worth. A whole day's worth of sun. Yeah, I don't think it's spaceweather.com. There's another one that's really, really awesome. I'll have to I'll have to look for it, Uncle Bill, and I will bring it to you here live. Well, for sure, Susan, it's really weird matter. Really weird. Some of the weirdest stuff there is is stuff that makes up suns. Weird stuff. No, you know, a lot of people think that they sort of know what's going on with the sun and how it's made and how it runs and everything else. And I'm I'm way too much of a skeptic, I guess. It's just the scientist in me, that pops out and is questioning everything all the time. So yeah, there's a lot of speculation and there's a lot of good information and a lot of good data that sort of points to certain things, um, um, things about the sun that we think we know. But yeah, I I much prefer sort of keeping an open mind and not really um, having anything really settled. Um, I think that makes for a lazy scientist, and I don't think that's good for anybody. Yeah, there are very likely thermonuclear reactions going on. Um, exactly where that is going on, that's still it's hard it's hard to know. It's hard to know for sure. The story is that the sun itself is just a big, huge thermonuclear reactor, and in the center of the sun is where all that takes place. So, but no, I don't know. I don't know. I've got. Well, I have doubts about mostly everything. So yeah, I doubt that too. But yeah, seeing these holes change shape, um, and if you've never seen a movie like this where it's actually showing the rotational motion of the sun spins on its axis about once every, I think, like every 25 days, something like that. It's a little bit less than a month, and one I one of the many interesting things about the sun is that, and I forget which way is which, but um, the higher latitude regions of the sun, both north and south, rotate at a different speed than the equatorial portions do. I don't remember which is which, whether the equatorial is a little bit faster. I'm sort of watching this movie, and I want to say that to me it does look like the equatorial regions are traveling a little further per unit time than the higher latitude uh, areas. But you know, I sort of see this more like a cloud floating on top of a surface, on top of a black surface. So yeah, I guess I just sort of see it um, in a different way than most. We can look at another one. Let's look at another one, eh? Let's look at. Why don't we look at the? Well, let's just look at this. This is probably not going to be incredibly interesting. The colorized magnetogram. It's probably not going to be that interesting to look at. Look, error with my dates. Shame on me. Shame on the programmer who wrote this, because you shouldn't have to do this, people. Okay, making the movie. This is 1 day's worth of data. This is from the 12th of February 2018 to the 13th of February 2018. So again, just like all the other sites, this shit is available like right away. It's absolutely fabulous to have access to this kind of data this quickly. You know, hours after the data is collected, I can grab it from the comfort of my dirty office. It's fabulous. What a great time, to be around, and a great time to be, sort of a armchair independent scientist. You've got so much data available to last you lifetimes. It's slowly loading. It's up to 2 megs. Got slow load times tonight. We're relatively slow out here anyway. It's, part of the rural lifestyle is slow down. You move too fast. So, yeah, things move a little bit slower out here in the darkness. I'm up to 3 megs, though. Yeah, that's a pretty big movie file there. Dun, 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 slowly, slowly loading. Some pretty interesting. There continues to be some pretty interesting discussions about the Tesla Roadster that's now in orbit. That that article that I don't think you, Uncle Bill, found, but it was somebody. It was somebody on this live stream. Maybe it was Tom. I think it might have been Tom. Tom Van Scotter. I think he's the one that, at least on this live stream, uh, pointed out that article about, the Roadster isn't going to make it through the first year because of the, I mean, that's a pretty intense environment. And yeah, I noticed, and I think maybe I mentioned this before, but I noticed that even, as soon as I first saw the Roadster up in orbit, um, if you look at it, it did not even have a shine at all. It was all lumpy, and I'll bet you that was the paint, or some of the paint, just boiling, right? So pretty interesting. Pretty interesting. Yeah, we'll see. We'll see what it looks like after a couple of years. Well, see, that's the interesting thing about space. Okay, because there's no air to sort of carry the heat around. Um, if you're facing the sun, you are like vaporizing because it's several hundred degrees, right? It's just like a laser beam, okay? And if you're not facing the sun, you are facing the rest of space, which is extremely cold, extremely cold. So if you're standing uh, out in space, okay, the half, sort of the half that's facing the sun is violently boiling and vaporizing, and your other side that is uh, facing the rest of space is freezing. Oh, excuse me. So it is not a pretty picture at all. So here's an hour, or here's a day's worth of colorized uh, magnetosphere. And the interesting thing here, and I don't know if you can see it or not, but I always see layers. I see layers in this, and I don't know how visible that is, but when you see it rotating like that, which I think is very, very cool. But this is just showing the magnetic field strength. I think the red is positive and the blue is negative. And these are locations of sunspots. sunspots are among many other things, are extremely magnetic um, areas on the sun. Yeah, rotisserie, rotisserie for sure. Yeah. All right. Well, cool. I think I'm going to start winding this up. I'm glad everybody came in. Always, always appreciate folks coming in for these things. But I have developed, excuse me, I have developed like a seriously nasty, nasty hiccups, and they are not going to go away until I perform sort of my magical trick to get rid of hiccups, which for me works 100%. But there's sort of a ritual involved, so it's not going to work until I get off. I get off. So I think I am going to go. I'm going to leave you for now. But the cool thing is that so far, what I've observed is that there is always tomorrow. Excuse me. So, since pretty good assumption that there's going to be tomorrow, that means that I am going to see you tomorrow. Tomorrow, same time, same place, but with no hiccups. None. None. I promise. I promise. Sometimes this astronomy just gets me way too excited. And when that happens, here come the hiccups. So I'm going to excuse myself for tonight. It's been a good hour. And yeah, Susan, I will definitely for sure see you tomorrow. Uh, and yeah, I will see pretty much everyone else. Same time, same place, 2 hours UTC, Astronomy Daily Live. Yeah, it's been a good hour despite the hiccups. And yeah, I think I'm going to exit this planet. Got to get up to the ship. Tonight, I've got to get up to the ship. So here I go. And I will see you all in about 23 hours. All right. Take care. Peace out. See you later. Bye.